Good day, viewers, and happy to see you here again. Today we want to solve this interesting exponential equation, as I'm going to be presenting the two methods. As the first method is power method, and the second method is Lambert omega function method. And let's see how we can apply the two methods. So let's start with method 2. As we have a to the power of 32 equals 2 to the power of a, let's try to introduce log on both sides. We have ln a raised to the power of 32. This equals ln 2 to the power of a. And from here, we consider this rule ln of a raised to the power m. This is the same thing as m ln a. Then we consider this as 32 multiplied by ln a equals a multiplied by ln 2. And let's try to do proper grouping, as let's say we divide both sides by 32 multiplied by a, and also 32 multiplied by a here. So 32 cancels 32, and a cancels a. Then from here we have ln a divided by a equals ln 2 divided by 32. So getting to this stage, let's try to rewrite this thing as, let's say we have 1 divided by a raised to the power n. This is the same thing as a raised to the power of minus n. As for this one, we have ln a divided by a. We can write this thing as ln a multiplied by a raised to the power minus 1. And while for this one, we can write this as ln 2 multiplied by 32 raised to the power of minus 1. Then from here, let's introduce e raised to the power of ln a. We consider this as a. Then from here, we have ln a multiplied by e raised to the power of ln a raised to the power minus 1. This equals, and from here we have this 32 raised to the power minus 1. We can write it as 2 raised to the power of minus 5. Then multiply by ln 2. So here we have minus 1 at the top of this. As we take this one here as one of the rule I applied already, as we have ln a multiplied by e raised to the power of minus ln a equals 2 to the power of minus 5 ln 2. Then this is missing negative, because the power here, we have to make sure that it resembles this according to the Lambert rule, which says that if you have omega of n e raised to the power n, this must be equals to n. And what this is missing is just minus. While introducing that negative here, we have minus ln a multiplied by e raised to the power of minus ln a equals, this one is also taking minus, as minus 2 to the power of minus 5 multiplied by ln 2. So let's do something to this side. If this is minus ln a multiplied by e raised to the power of minus ln a, this equals, this is just like minus 1. And let's take this negative to the power of this 2. So here becomes 2 raised to the power of minus 5 multiplied by ln 2 raised to the power of minus 1. Okay, so here we have minus ln a multiplied by e raised to the power of minus ln a equals, from here, if I write this thing as 2 to the power of minus 8 multiplied by 2 to the power of 3, we agree that this is still the same thing as 2 to the power of minus 5, right? So multiply by ln 2 to the power of minus 1. And 2 to the power of 3 here is just like 8. And by taking this 8 back to this, we are going to have this as minus ln a multiplied by e to the power of minus ln a equals 2 to the power of minus 8 multiplied by ln 2 to the power of, if this is 8 and this is come as 2 to the power of minus 8. And I want to make this one just like having exponent as this. So what we do here is we write this as minus ln a multiplied by e to the power of minus ln a, and this equals, for this I can write this as e to the power of ln of 2 to the power of minus 8 multiplied by ln 2 to the power of minus 8, because ln and e, they are inverse to each other. Now by taking omega to both sides, we are going to conclude that we are taking this, which is minus ln a, equals, and we are also taking this, which is ln 2 to the power of minus 8. And from here, let's take minus 8 here. We have minus ln a equals minus 8 ln 2. Alright, so from here we are going to cancel this negative, as we have ln a equals 8 ln 2. Okay, so after the cancellation of this, let's try to take this one back, as we have ln a equals ln 2 to the power of 8. And by cancelling ln and ln, we are going to have a equals 2 to the power of 8, and which is the result to the value of a as the first method. And let's consider the second method. So for the second method, as promised, that we are going to be using two methods. Let's say the power method. If you are just coming to this channel, please do to like, share and subscribe, and turn on the notification bell for more videos. So here we have a to the power of 32 equals 2 to the power of a. So for the power method, suppose I raise both sides of this equation by 1 divided by 32 multiplied by a. This also equals 2 to the power of a multiplied by 1 divided by 32 multiplied by a. So from here, 32 cancelled and a also cancels a. So therefore we have a raised to power 1 divided by a equals 2 to the power of 1 divided by 32. And suppose I rewrite this thing as 2 to the power of 2 multiplied by 1 divided by 64. We agree that this is still 1 divided by 32. And for every 2 to the power 2, we consider it as 4, and all raised to power of 1 divided by 64. Then again, we have this as 4 to the power of 2, all raised to power of 1 divided by, when we multiply this one by 2, we are going to get 128. And 4 to the power of 2 equals 16, all raised to power of 1 divided by 128. And similarly again, we have 16 to the power of 2, all raised to power of 1 divided by 256. As 16 to the power of 2 equals 256, and everything raised to power of 1 divided by 256. And remember that the whole of it equals a raised to power 1 divided by a. And by comparing this, it is therefore known that a equals 256, as 256 is the answer, but what we get above is 2 to the power of 8. Worry less, a is still the same thing as 2 to the power of 8, as we get the same answer when we apply the power rule or exponent rule, or when we apply the Lambert W functions. So this is how to solve this. I hope you learned something. Thanks for watching, and if you are new here to this channel and you find this video interesting, please do to like, share and subscribe, and turn on the notification bell for more videos. Never stop learning. Bye bye.